All right, buddies, part two of what we missed today in class, or what we might need to hear again. A lot of jargon on this page, a lot of mathematical vocabulary that's helpful, but also like adds a layer of confusion that I don't always appreciate. That's life. So two complex numbers of the form a plus bi and a minus bi are called, they have a special name. And you'll hear me use this word from time to time. They're called complex conjugates. Complex because they're a complex number. And conjugate, what conjugate means in this context is that the numbers are the same, but the signs between them are different. So basically, anytime we have something of the form, like this is an example, right? The 2 and the 2 are the same, the 4i and the 4i are the same, but one's plus and one's minus. Those are considered complex conjugates. Same thing for example 3. This number and this number are the same. The imaginary components are both with a 5, but one's plus and one's minused. That makes them a complex conjugate. So we, as a math person, or someone who wants you to read math, we say that more as like we use symbols. We don't get specific about the numbers. We're just saying if it's the same thing here and the same thing here, whatever those numbers might happen to be, and one's plus and one's minused, it's a complex conjugate. I don't expect you to walk around using the word complex conjugate, but I do expect you to know that if I say complex conjugate, which I will say, this is what I'm talking about. And the nice thing about this is there's a shortcut. So I'm going to first do this the long way, and then I'll tell you what the shortcut is. And this is different how I do. This is different from how I did it in class. Maybe this will make more sense, although I think it was fine in class today. So let's pretend like there's not a shortcut. The shortcut will go in this blank here when I finish. Let's just do this like we did the previous example, where we're going to treat this like the same way I would treat the problem 2 plus 4x and 2 minus 4x. I really have to practice writing 4s with this Como pad thing. They always end up looking like 9s. So if I had a problem like this, right, and I was an Algebra 1 student, I'd be like 2 times 2 is 4, and 2 times negative 4x is negative 4x. And then I'd move on to the next guy. 4x times 2 is oh wait, hold on, Mr. Dupsick, your multiplication's wrong. You're right, thanks for that catch. 2 times negative 4x is negative 8x. Beg my pardon. Then I move on to the second term. 4x times 2 is positive 8x. 4x times negative 4x would be negative 16x squared. And when I go to combine these like terms, shazam, those cancel, leaving me 4 minus 16x squared as my final answer, right? So if I was to do those same things here, I would have 2 times 2 is 4. I'd have a negative 8i. I'd move on to the next one. 4i times 2i is positive 8i. 4i times negative 4i squared is negative 16i squared. These would knock each other out, and I'd be ending up with 4 minus 16i squared. The only problem is, unlike the x squared where I can't do anything else, now I've got an I squared. I squared is the same thing as negative 1. So negative 16i squared, if I take negative 1 times negative 16, I end up getting 4 plus 16, which is just one real number, 20. Now here's the beautiful thing that I'm about to teach you with the pattern. Every time this pattern exists, every time it's the pattern where this number matches this number, and this number matches this number, and one's plus and one's minus, every time that happens, I can skip all of these steps and just say, oh, you know what's going to happen? Whatever this number is, I'm going to square that. That's a 4. And whatever this number is, not the I, just that itself, whatever that is, I'm going to square that. And then I'll add those two things together. 4 plus 16 is 20. I'm done. This is all the work you have to show. So the shortcut is, if it's a plus bi and a minus bi, just square that a and square the coefficient on the I term and add them together. So let's try to apply that to the second example here. First of all, I got to make sure the pattern fits. Are these in fact complex conjugates? Yes, they are. I can tell because it's the same number here as here. The imaginary component has the same coefficient. One's plus and one's minus. So the shortcut is take this value 3 and square it. Take the value in front of I, Don't take the I with it, just the value in front of I, 5, and square it. Add those two things together. And whatever 25 plus 9 is, that's your final answer, 34. If you don't feel good about that, if that makes you feel a little uneasy, then I suggest, first of all, good for you. I'm glad. It should make you uneasy. I don't ever use a shortcut myself unless I fully understand it. Anytime when I was a kid and I tried to use a shortcut before understanding it, I always felt like I always forgot it, you know? So if this makes you uneasy, then take the time to go 3 times 3 is 9. 3 times negative 5i is negative 15i. 5i times 3 is 15i. 5i times negative 5i is negative 25i squared. These cancel. This becomes positive 25. So 9 plus 25. And yes, I'm putting on my boring voice for that because it's like I'm doing this rote thing that I've done 1,000 times, right? But I also have a lot of confidence in that procedure. And I see, oh yeah, that gets me to what the shortcut told me to do anyway. So the more time, if I don't like this, if it's making me uncomfortable, but I know I'm supposed to get there, and then I do the hard work and see that I get there, then I gain confidence in the shortcut, and I'm more likely to remember it. I hope that makes sense. You guys can see all the homework that's posted. There's an additional form to fill out with a quick video to watch. So this will all be well, yeah, you're watching it. I was about to say where this is posted, but if you're watching it, you know where it's posted. So any Hoozlebees. If you have questions, email me. Office hours Tuesday, Wednesday, Thursday, Friday from 3 to 3:30. Math tutor every period but first. Email me 24/7.